In this course, we'll set up and do security testing in a virtual lab. To create the lab, we'll use a virtualization system called VirtualBox, which will run on a Windows 10 host computer. We'll use a Kali Linux virtual machine to do the testing, and we'll load some target systems into the lab. There are a number of advantages to using a virtual test lab. Virtualization is a very easy way of setting up a testing environment, and avoids the need to purchase racks of computers and networking equipment. I'm using an i7 Shuttle PC to run a virtual test lab. But with the efficiency of modern virtual environments, almost any computer with enough memory is powerful enough to do this. 8 GB is sufficient, but I like to run on a 16 GB system. Using a virtual lab for testing ensures that all testing is contained within a prescribed environment, so that we minimize the risk of test scans and probes leaking out onto the internet, and avoid our legitimate testing activities inadvertently becoming illegal activities. This is an important consideration in all aspects of penetration testing. Virtualization is not only a simple and safe way to do testing, but it also offers a further advantage when dealing with potentially dangerous tools. Using a virtual environment, a tester can take a copy of a known good state and save it as a snapshot. After running a testing session, the snapshot can be used to recover the lab and remove any malware or traces of malicious activity. Before we go any further, let's look at what we mean by virtualization. The basic structure of a normal computer is a hardware layer, on top of which sits the operating system. The operating system directly interacts with the computer hardware and controls how the hardware is accessed. On top of the operating system are the various applications which use operating services and, through them, the hardware resources. For a native or hardware-level virtualized system, there's another layer, the hypervisor, which sits on top of the hardware. This provides a virtual set of hardware on top of which sits the operating system and its applications. Using the hypervisor enables multiple operating and application system stacks to operate. These are called virtual machines, or VMs. The hypervisor manages the virtualization of input-output services, mapping devices in the virtual machine to the hardware devices and managing contention. An example of this is the Microsoft Hyper-V hypervisor, which was introduced with Windows Server 2008. Another example is the Proxmox Virtual Machine Manager. Native hypervisors are installed prior to installation of any operating systems. The hypervisor includes a Virtual Machine Manager, or VMM, which can be used to stop and start virtual machines and to configure how they operate. In the case of Hyper-V, the hypervisor management sits in what's known as the parent partition, and guest operating systems sit in child partitions. VMs don't have direct access to hardware resources. The VMM service in the parent partition is responsible for all access to hardware devices, and manages access on behalf of all VMs. A VM hardware request is redirected by its virtualized service client across the VM bus to the appropriate device in the parent partition. Software virtualization is another approach that can be used. In this approach, the virtualization manager operates as a standard application on top of a host operating system. To do this, any privileged operations within the operating system must be carried out by a VM-safe routine in hypervisor memory. This is achieved by a module in VirtualBox called the Code Scanning and Analysis Manager, working in conjunction with a real-time patch manager which identifies and replaces unsafe code with safe code routines. Processors such as the Intel VTX include hardware-assisted virtualization to enable virtual machines to maintain their own address space and deliver additional performance. Two popular software-assisted virtualization systems for Windows are VMware and Oracle's VirtualBox. Parallels is a popular virtualization environment for Mac systems, often used to enable Windows functionality on Mac computers. In this course, we'll be using VirtualBox. VirtualBox is free for personal use. It's available for the x86 type of processors and runs on a range of operating systems including Windows, Linux, Macintosh and Solaris. The base package comes as a free download and contains everything we need to run a virtual environment. An extension pack is also available, which includes extra features. To learn more about virtualization, take a look at the virtualization courses available in the LinkedIn Learning Library.